Right now what we're going to do is actually we're going to find the quadratic relation first, and we're going to write the quadratic relation in vertex form, and then we're going to change that vertex form of the equation and convert it into standard form. So if you take a look at the first example we have here on the left-hand side, it tells us that our a value is equal to 2 and that the vertex is at 5, 1. Well, the important thing to know there is that because we know what the vertex is, we can actually write this equation in vertex form. So bear in mind that when we're writing out a vertex form of a quadratic equation, all vertex form is in the form y is equal to a times x minus h all squared plus k. And since we know that the a value is 2 right there, and we know that the 5 value, okay, so 5 represents the h value, and the 1 is the k value, we can substitute those values into the original form of the quadratic equation. So I'm going to substitute in those values now. Instead of a, I'm going to put in 2. And instead of x, I'm going to put in positive 5, which becomes negative 5 squared. And then my k value is positive 1. So what I need to convert then, so this here is my vertex form of the quadratic equation. I'm going to just quickly put a VF beside. So that's my vertex form of the quadratic equation. Now what I need to do is actually convert that into standard form. So again, in order to convert it into standard form, I need to multiply out the binomial that's actually in the middle here. So I'm going to quickly write this out. I'm going to put in y squared is equal to 2. And I'm going to expand out this x minus 5 all squared, because that just means x minus 5 times x minus 5. I'm going to write in x minus 5 times x minus 5. And then again, plus 1, because we haven't dealt with that plus 1 yet. So the next thing that we are about to do is we're going to multiply through and expand out those two binomials. So I'm going to put in y is equal to 2 times, I'm going to multiply my first, so x times x gives me x squared. X times negative 5 gives me negative 5x. Negative 5 times x gives me another negative 5x. And negative 5 times negative 5 gives me positive 25. And again, I still haven't done anything with that plus 1, so I need to carry it down. So now I'm going to simplify what's in the middle. So I have 2 times x squared minus 10x, because negative 5 minus 5, so negative 5x minus 5x gives us negative 10x, plus 25, again, plus 1. So now that I've gotten a simplified version of those two binomials in the middle here, I need to multiply through. I have 2 times everything that's in this bracket. So again, I have 2 times x, 2 times negative 10x, and 2 times positive 25. So I need to go through and multiply those things and expand that piece out first. So what I'm going to do then is I'm going to multiply through, and I end up with 2 times x squared times 2, and then 2 times negative 10x, that gives me negative 20x. And then lastly, I have 2 times positive 25. So that's positive 50. And then because I've multiplied everything out of my brackets, I still have that plus 1. So my final answer then is going to be 2x squared minus 20x plus 51. Okay. So I want to go back and show you a second example here, just on the right-hand side. And in this case, again, we have a is equal to 3, so we know what our a value is. And it says that the minimum value is negative 9. Minimum value is always given to you by the k value. Okay, so we know that our k value is negative 9. And we know that the minimum value happens when x is equal to negative 3. And the minimum value on a parabola only ever happens at the vertex. So if the k value is negative 9, that and it happens at -3, then that happens to be your h value. So again, I'm going to write this out in vertex form. Again, the equation for vertex form is y is equal to a times x minus h all squared plus k. And now I'm going to substitute in the values that I have. So I know that the a value is equal to 3. The x value is -3. So if I substitute, the x value is unknown. We know that our h value, rather, is -3. And so if I substitute that in, I get -1h, or -1 times -3, and that equals +3, and that's all squared. And my k value is -9, so I can put in that -9. So this piece right here, this represents the vertex form of this particular equation. So now I want to go through and I want to expand out the binomial in the middle and solve and convert this from vertex form into standard form. So I'm going to end up with y is equal to 3 times, again, x plus 3 times x plus 3. I'm just expanding that piece out. And then -9. Okay, and we're going to keep bringing that -9 down until we finish using it. So I'm going to expand out my two binomials here. So y is equal to 3 times x is is x squared. X times +3 is +3x. +3 times x is another +3x. And +3 times +3 is +9. And then again, -9. So what I've done is I've expanded this out, and so now I need to collect my like terms in there. So I'm going to actually simplify this. So I'm going to do y is equal to 3 times x squared plus 6x plus 9 all -9. Now I have to use my distributive property just like I had on the other side, and I'm going to multiply that 3 times x squared, 3 times 6x, and 3 times +9. So if I do that, then I end up with y is equal to 3x squared. 3 times 6x is +18x, and 3 times +9 is +27, and then -9 on the end. And so now I have to collect the last of my like terms. That gives me 3x squared plus 18x plus 18. Okay, so just by going through that process, again, we have solved and converted from vertex form down into standard form both times. Okay? So we can always convert from vertex form into standard form, and that's an important skill that we're going to be able to use throughout the course of this unit.